In question 16, we're asked to find the interquartile range. And when you look at a box plot, you need to know that this part of the box represents the interquartile range. It's the difference between the lower quartile, this line here, and the upper quartile here, and this middle one being the median. So we're asked to calculate the length in kilometers between here. So the scale on this one is pretty nasty. This is 4.5 and this is 5, and I've added in these little extra marks here to help me. So I know that's 4.6, 4.7, 4.8, 4.9 and 5. So this one is 4.9 and this one is 4.8. So this actual line here, the lower quartile, is smack bang in the middle at 4.85. Now the upper quartile is much nicer. 5.5, 5.6. So this one is 5.6. So it's the difference between these two numbers. So if I add on a 0.15, I get to 5. So 0.15 plus 0.6 is 0.75. Sometimes you can look at a scale for a little while, but just try and experiment with it and just work out what's actually happening. But that's it, 0.75, the difference between the lower quartile and the upper quartile. Now, I'll do B in the same video. It says there are 80 players in the whole sample. So this whole picture from here to here is represented by 80. Now, it's working out the number of players who are more than 5.6, which is represented by this part here. Now, the only way you can answer this is knowing that this is 100%, but the difference between the lower quartile and the upper quartile is the middle 50%. So this is the lower 25%, the middle 50%, and the upper 25%. So which means everyone that ran more than 5.6 was 25% of the people. So all we have to do is find 25% of 80. So 50% is 40, 25% is 20. And that was the answer.